inside the world's largest chip factory. Wondering where the largest chip factory is located and who owns it? Well, you will be amazed to learn that the most expensive factory ever built belongs to the most influential tech company you probably may have never heard of. Remarkably, TSMC of Taiwan makes use of cutting-edge lasers to engrave intricate details much smaller than a part of a size of a red blood cell onto the purest hunks of wafer-thin silicon, divided into 1,000 pieces. Before we get further into this video, make sure you hit that like button. Kindly subscribe to our channel, and don't forget to turn on the notifications so you can keep up to date with all our most exciting and latest content. There's every chance you already have at least one product from these factory-integrated circuits, better known as chips, right in your car or your home. But wait a minute, what's up with the eerie yellow lighting inside? Why are these guys such a freak for neatness? With the whirling rumor of an uprising tide of geopolitical insecurity, would this massive factory soon be harshly swept away on the tide? Take a walk with us as we put on one of those super weird suits and step inside the world's biggest computer chip factory. There is absolutely no doubt that if you were called up in your sleep to list the world's most important chip makers in the market, you'd probably go for companies like Samsung, AMD, Intel, or ARM. Well, it's no fault of yours. Many people have never heard of the Taiwan Semiconductor Manufacturing Company, popularly referred to as TSMC. Yet, this single company controls over half the market for already made chips. The company is attractively sprawled across several constellations of buildings in Taiwan, with a reported cost of over $17 billion. No doubt, this is the most expensive factory ever built, and incidentally, it is just a single factory. Want to know how expensive this factory is? A good result would be a comprehensive study carried out on Tesla's shiny new Gigafactory in Shanghai. Tesla's factory reportedly only cost a fifth of what the TSMC factory swallowed during its creation. As a company, TSMC decided a long time back that it was quite comfortable avoiding the publicity and fame a firm of its size naturally would have attracted. Instead, the firm's significance was swallowed up into relative oblivion, making chips for other companies like Huawei, Apple, and so many other automobile manufacturers around the world. This laser focus, no pun intended, on what TSMC calls foundry services empowered it to focus entirely on breaking new boundaries in the minuscule scale and peerless intricacy of its chips. Let's take a glance at the overview of what the company actually does. Back in 1965, an Intel employee by the name of George Moore suggested an idea that the number of transistors on a particular chip would likely double every 2 years, while the cost of transistors reduced by half. Surprisingly, Moore's theory has stayed true for the past 6 decades. And this is all thanks to the work TSMC contributed to the chip-making industry. This law has also been the major reason for the ultimate speed our computers are attaining these days, and their capability over time. According to Moore's law, transistors in the second decade of the 21st century are almost impossibly small, whatever that means. Most laptops, for instance, rock TSMC-made chips without our knowledge. These chips individually have over 170 million transistors that are carefully crammed onto each square millimeter of silicon, with some features just 5 nanometers across. Oddly, a virus is about 10 times that size, and a red blood cell is about 1,000 times bigger than these transistors. Let's get this clear. 5 nanometers is fully 100 times shorter than the wavelength of visible light. Now, this is about 600,000 times smaller than the strand of your hair. Are you getting hold of what I'm trying to say here? Agreed, this trying to explain to a layman's level is really techy, but that's just the start. TSMC has already inked contracts to supply chips featuring 3 nanometer architecture. It has even, in a highly speculative process involving semi-metal bismuth, produced 1 nanometer chips. Engineers call those sorts of chips two-dimensional objects, since that's basically what they are. Straightforward, right? I guess sometimes we don't need to beat around the bush on certain things. Anyway, that's all in the future. Let's take a detailed look at how TSMC makes its cutting-edge production chips in this present age. Interestingly, the heart of the action in a TSMC factory, or the fabrication plant, mostly referred to as the fab area of the plant, is the so-called clean room. And you're probably wondering what a clean room is in a fabrication plant and why it is so important. A clean room is an area or space left in a state where there are fewer than 15 to 20 particles of dust per cubic foot of volume. In TSMC's case, its clean rooms are, more precisely, level 10 clean rooms, which basically means they're kept in a state where there are fewer than 10 particles of dust per cubic foot of volume. Impressive, right? And that's not all. The factory's clean room is as big as, or even larger than, about 22 football fields or 160,000 square meters in size. As you may have already imagined, working in such nanometer scales means that even the tiniest mote of a dust particle or foreign matter could cause a lot of havoc with the delicate circuitry. So workers in the fabrication plant, which by the way are over 50,000 people, need to thoroughly scrub up before heading to work. That means tying their hair up in a net, stashing their shoes in a locker, and undergoing a thorough and thoroughly futuristic air shower. Yup, working here entails a lot of protocol, and not to mention the carefulness which no doubt would come with a load of stress. Regular air from the outside world passes through many layers of filtration systems just to keep out the unhelpful particulates. Various other environmental disturbances, like random vibrations, fluctuations in temperature, swings in humidity, even magnetic fields are securely controlled for. As luck would have it, TSMC's most important raw material, silicon, happens to be the most abundant element found in the Earth's crust. Quartz sand is refined into molten silicon with over 99% purity. For years, silicon was delivered to the cleanroom in cylinders that measured about 8 inches in diameter. Although TSMC has made a lot of refinements to the process and also had massive hikes in sales, this simply means that a company starts out with the 12-inch hunks of silicon. It also means that they can fit even more onto the same block of raw material, driving those all-important economies of scale. More interesting is the fact that this cylinder is sliced into thin wafers, and at the super fascinating 3 to 5 nanometer scales that the firm's employees work at, precision is a must, as even the slightest mistake would render the cylinder a waste. How does TSMC get this done? The silicon wafers are first treated with chemicals that include phosphorus, arsenic, and boron to elevate conductivity and other useful properties. These wafers are then moved to what's understood as the division area, where they are placed in an oven tube that has its gas flows and temperature minutely controlled. This is monitored in order to create an insulating silicon compound film on the surface of the wafer. No doubt, these chips are expected to insulate as well as conduct before they can be okayed. The next leg of the process is called ion implantation. Here, implants charged ions into specific pre-chosen regions of the silicon wafer. Without getting all technical, the level of conductivity in the final chip is manipulated by carefully adjusting the depth of ion penetration at this stage. From this stage, the wafers are moved to a so-called CVD, or the chemical vapor deposition area of the fabrication plant. In this part of the plant, a solid-state reactant, generated from chemical reactions in the reaction chamber, is then deposited onto the chip as a thin light-sensitive film. This is a key detail you may need to get your head whipped around. The chip architecture is nowadays so fine that it's carved out without the use of machine tools, but rather the use of blasts of light. This special magic takes place in the photolithography area of the fab. Photolithography area of the fab. Light is shown through a chromium plate imprinted with the layout of the chip as created by designers. In the case of the M1 chip, Apple, however, the light that makes it through engraves into the light-sensitive film, which is what then carves out all those minuscule features and pathways. Another remarkable feature of the chip's design is that they are jealously guarded marketable secrets. The dense, complex architecture of every layer of the chip has between 20 and 30 layers carefully packed together, and then transferred from the computer-aided design systems onto photomask. These photomasks are known as plates or reticles. Once the chip pattern is on the silicon, the wafer moves to the engraving area, where fine chemistry is utilized in stripping away any extraneous silicon. Once this is over and done with, it is then polished until it's flat, carefully inspected, and then stacked to make the final chip. All the parts of the chips are ferried around using robots hanging from the ceiling. You have to agree that 12-inch silicon cylinders, which collectively travel some 400,000 kilometers every day, are generally too heavy for people. And with that rate of movement, it sure is a busy place. You're probably wondering about the yellow light the factory's cleanroom is securely bathed in. We earlier mentioned that light is what TSMC utilizes in generating these chips. So, light is a vital part of fabrication. As for the yellow light, it has a long electromagnetic wavelength and as such doesn't interfere with the lithography process, since shorter wavelengths like blue light might become a big challenge in the factory. Remarkably, TSMC is presently expanding onto the Chinese mainland in a bid to open a plant in Europe and the United States, and also win favor with the People's Republic. Naturally, the greater TSMC gets at making and shipping their products around the world, the more their wares will become more reliable for the world to use. That's it, guys, on what's the world's biggest chip factory. What do you think? Is it fraudulent for other companies to commercialize TSMC products as their own? If you're given an opportunity to visit a fabrication plant, would you grab it with both hands? Or just take a tour from a distance? Check out our other videos and subscribe to be part of the fun. Click on the notification icon so you can see our new videos as soon as they're uploaded. That's it for now. See you in the next video.